Okay. So starting up with the chapter number 7, chemistry, the calculations of quantifications of elements and compounds. Elements and compounds. So this has to be connected with the previously learned basic principles about the matter, the structure of matter and all. I hope you remember all those things. Okay. So there you learned about the atomic measures like atomic number, mass number, electronic configuration, okay, chemical formula, those stuff you learned. And here you are going to learn about, okay, calculations or how to quantify, how to measure the elements and compounds by mass, okay, and some other measurements specifically we learn here, right? So almost about 7 to 8 topics are there here. 7 to 8 topics are there, right? So we learn about the measurements starting from AMU, atomic mass unit. But before that, we recall some things. That is, when you come for matter, what is called matter? Matter which occupies space and having a mass. Which occupies space and having a mass is what we term as matter. Okay. And this matter we are dividing in 2 ways. What are the 2 ways? One is based on the physical nature, the physical arrangement of the particles, and the other one is according to the chemical composition. According to the chemical composition. So physical nature, when we take solid, liquid, gas, we are dividing into 3 stages, 3 physical arrangements. What are they? Solids, liquids, gases. Solids particles are tightly packed. Liquids slightly there are gaps between. Not a big gap. Comparing to solids, they have some gaps. And gases, a lot more gaps are there between them. Okay. So physically, that is how they are arranged. And chemical combustion is what basically we take here. Chemical combustion we take. We are dividing them into 2 as pure substances and non-pure substances. Pure substances, elements and compounds. Non-pure substances or mixtures, homogeneous and heterogeneous. About their initial theories you learned in unit number 3. Okay. So what I need here is this area, elements and compounds. When you come for elements and compounds, elements are what chemically combining to form compounds, right? Elements chemically combine to form compounds. And you know, more than 100 elements are formed. All those elements are made of their own atoms. Made of their own atoms. Hydrogen element is made up of hydrogen atom. Get this idea properly. That is needed for all lesson. Hydrogen element is made up of hydrogen atom, oxygen element is made up of oxygen atom, carbon is made up of carbon atom. So each of the element, they do have their own atoms. Atom is the basic building unit of matter, right? And compounds are basically containing molecules. Compounds are basically containing molecules. For example, we take water, right? Distilled water, let me do it. Distilled water. It is a compound. So this distilled water is made up of water molecules. What molecules are they? Water molecules. You take a glass of water, it's totally water. Okay? It's distilled water. Distilled water we don't drink. Okay? We are drinking water. We say that containing minerals, ions, and all. Distilled water means only H2O. No any other substances, only H2O. So now this distilled water you drink. Okay, distilled water you drink. It contains only water molecules. So this entire part within the container is said to be water as a compound. Distilled water as a compound. Now let's say 100 ml of water is there. In this 100 ml of water, how many water molecules? That means how many H2O? What is H2O? How many H2O molecules are there? Okay. So that is the molecule we see. That is how many H2Os. H2Os are there. So H2O is one molecule. Likewise, thousands of H2O molecules may be there in distilled water. Distilled water. Do you understand that? Okay, thousands of molecules will be there in distilled water. So water molecules, H2O is one molecule. So accordingly, compounds contain molecules. Some elements are also there in the form of molecules. For example, oxygen element contains oxygen atoms. Oxygen gas, which is there in the atmosphere, it is made up of oxygen molecule, O2. O2 is a molecular form. Hydrogen gas is made up of H2 molecule. H2 is not an atom. H2 means two hydrogen are there. Two hydrogen means two hydrogen atoms are there. So H2 is a molecule. Oxygen O2. Two oxygen atoms are there. O2 molecule. Hydrogen H2. Two hydrogen atoms are there. H2 molecule. Is that clear? So molecule is combined with atoms accordingly. Atoms may be the same type of atoms or different types of atoms form molecules. So that is a clear idea between atoms and molecules. Atoms are combining chemically to form molecules. If it is the same type of atoms, the molecules formed we name as homoatomic molecules. What atomic molecules? Homoatomic molecules. Different types of atoms in their combining become it as heteroatomic molecules. What atomic molecules are they? Heteroatomic molecules. Homoatomic molecules are made up of same type of atoms. Heteroatomic molecules are made up of different types of atoms. Is that clear? Okay. Right. So now this is the picture we basically need. Why? We have to find out the number of atoms, number of molecules separately in this lesson. And there are some theories going up with atoms, some are they are going up with molecules. So did you understand the theory clearly about these atoms and molecules? Okay. So atoms combine to form molecules. Oh, molecules contain atoms. So for example, let me take H2O. H2O. It is a molecule. It is a molecule. In this H2O molecule, how many atoms are there? 2 into hydrogen atoms are there. 1 oxygen atom. Right? So 2 hydrogen atoms, 1 oxygen atom. Altogether, how many atoms are there? 3 atoms are there in 2. Do you understand? So this is how we find out the number of atoms. Clear that? Clear? H2O molecule you take. 2 hydrogen atoms and 1 oxygen atom is there. Totally 3 atoms are there. Totally 3 atoms are there. That is how H2O molecule is formed. Okay, fine. So shall we go to the tube? Take this note first. This part. Okay, this part. And yeah, first we do this. Go to write a book because I have to erase this. Go to write a book. Take the topic as quantification of matter, quantification of elements and compound. Hurry up. Take the topic quantification of elements and compound, unit number 7. Okay. Listen carefully. First you write this and make it in big letters. Okay, font size you have to increase. This is the highlighted area. Below that you have to take this as an example and this as well. Make it fast. Quantification of elements and compounds. Quantification of elements and compounds. Make it fast, please. Please make it fast. Write it down, write it down. Hurry up. This part, only this what I have written, okay? What I have written only you have to take the note. Done? Any one of you didn't get those papers yet? The papers you have done? You didn't get them? Finished? So shall we go to the tutor now? Please start writing this part in the first page. Part to do it, okay? On a tutor? Anyone having exams this month? Second term? Second term. How many chapters? 14. Up to 14 done? 18. How many chapters? 12. Part 1. Third term. School is different, right? All 20 chapters done then. We made fast. Stop talking. Okay. Done, right? Done? Done? When is the exam? School exams? Oh. Now we are having some sort of series seminars this month, inshallah. Sundays. Yeah, you'll get the message by tomorrow, inshallah. By tomorrow, you'll get the messages. Next week onwards, just starting. Series like it goes. Maybe 3 or 4 weeks. Okay, still writing. Again. Fine. Now, pure substances, if you could remember some of the examples to recall with these atoms and molecules. So you can see here, sodium chloride is a molecule, right? Sodium chloride is a molecule. Sodium chloride molecule is made up of sodium atom and chlorine atom. Sodium atom and chlorine atom. So how many sodium are there? One sodium and one chlorine. Totally two. And when you come for carbon dioxide, it is made up of. Carbon dioxide is a molecule, is made up of one carbon, two oxygen, altogether three atoms. CH4, methane or methane. One carbon, 1, 2, 3, 4, 4 hydrogen. Totally 5 atoms. Got it? Hydrogen chloride, hydrochloric acid, HCl, 2 atoms totally. H2O water, 2 hydrogen, 1 oxygen, altogether 3 atoms. 3 atoms. So this is how the molecules are formed. Molecules are formed. And now we come for the point. Our lesson, the atomic mass unit. Atomic mass unit. Read and see what it gives you there. The bold one, the mass of the unit relative to which the masses of other atoms expressed is called atomic mass unit. Can you understand? Can you? For those having the exams within 1 or 2 weeks at school, should have been totally done this lesson at school, right? Okay. You should have it totally done at school. Okay. Then you should know what it is. If you don't know the atomic mass unit, mean the entire lesson you don't know. That's what I am saying. This is the basic part here. Okay. Mass of an atom. Okay. What else? What is this atomic mass? Any of your answers? Yes. Atomic mass unit. Yeah. Okay. Yeah. Anyone else? Fine. Let's learn this properly. Okay. Look at this. Look at this. Now, can you remember in lower grades, somewhere between 1, 2, 3, we don't learn about these meters, centimeters, and all, right? We don't learn about meters in grade 1, 2, 3. But how do you measure? You take a marker or you take a duster. You take this as 1 unit. Okay. And you measure 1, 2, 3, can you remember? 4. You measure. And you say duster units. By the duster units, it gives 8 units, for example, or 10 units. So the width of the board is 10 duster units. The length of the board is 20 duster units you are giving. So what is the unit you are using here? Duster. The length of the duster. Or I am using the marker. The length of the marker, I take it as a standard value for me to measure the others. So according to the marker, I measure the length of the board. 20 marker units I am telling you. Okay. 10 marker units of width I am telling you. The table when I take, okay, 8 marker units, for example, or 10 marker units. So marker unit I'm taking as a standard relative to this person. Compared to this person, we measure the others. Okay, everyone listen here. Compared to this, we measure the others. I'm measuring the length of my arm. 1, 2, 3, 4, 5. Compared to this. I'm measuring the length of the width of this duster. Now you see, compared to this, somewhere half of the marker unit, right? But it is not always more than 1. It may be less than 1 also. So this is half of the marker unit. Got my point? So accordingly, compared to one person, we measure the others. Likewise, why we need these atomic mass unit here is elements and compounds are, guys, very small. How much small are they? Now, When you take 1 out of 1000, you have an idea. 1000 pieces you are dividing, only 1 out of that. Now 10,000, 100,000. Okay, a million, 10 million. Like it goes with, likewise, about 23 zeros. How many zeros? 23 zeros we have to take when we want to measure the real mass of elements. Okay, an atom of an element when we are measuring, it is about 10 to the power minus 23 we have to take. That is, we have to divide by 10 to the power 23 or 10 to the power 24. So that's not so easy. Very hard, hardly it has to be measured. Means that much smaller they are. So we can't see them by our naked eye. So can we calculate all of them always like the same? It's hard. So we need a standard measurement, a comparing measurement, a relative measurement we need. So we come for AMU. We come for AMU. So what we do in AMU? What we do in AMU, it is AMU, atomic mass unit. It is taken relative to AMU. We measure the mass of other atoms. What do we do? Relative to AMU, we measure the mass of other atoms. Okay, we measure the mass of other atoms. Then what is this AMU? That is the standard unit we are using. To whom relatively we are measuring, that is the AMU. Initially, the AMU that we used was mass of hydrogen 1 bond at first. And then they used 1/16 the mass of oxygen 816. That was also changed. And today, up to date, they are using 1/12 the mass of carbon 612. Carbon 612. You understand that? So 1/12 the mass, that means the real mass of carbon 612. Carbon 612 is an atom, right? Can you remember what it is? What is the number we are writing here? Atomic number. When you take the standard symbol, left bottom we write the atomic number. Left top we write the mass number. So mass number 12, atomic number 6, 612, 613, 614, carbon are all there, but we are taking 612 carbon. So this 612, the real mass is there. The real mass we are dividing into 12. 1 out of that 12 we take it as AMU atomic mass. You understand that? Is that clear? 1 out of the 12. I'll explain that once again. So you see here, accordingly, this is how initiated the AMU. Okay, this is how we initiated the AMU, atomic mass unit. Mass of an atom relative to whose the mass is taken. Right? So you see now the mass of the unit relative to whom the masses of others are measured. Mass of the unit relative to whom others masses are measured. You understand that? Mass of the marker relative to whom the mass of others are measured. For example. Likewise, 1/12 the mass of carbon 612, that is what we use today as AMU atomic mass unit. The lesson is very easy, but hard. What do you mean? It's a very easy lesson, but always the students get complicated with. How many times you do, still you go wrong. Something like the motion. Physics also have lesson like that. Motion, how much you do, still you mistake. Why? Easy you forget. Easier you do when you write answers, easier you forget. Because of no continuous practicing. You are not consistent in that. This is also the same. When you learn, it's very easy. But fundamentals should be correct. That's why I told you, if you don't understand this part, most of the parts will be there. Because connected to this only, the rest of the parts also they are going to build up. Okay, and initially about the atoms and molecules. Without that idea, you can't learn this. So I hope this part is clear. Okay, what is AMU? That is the unit whom we take as to compare the masses of others. So today we are using 1/12 the mass of carbon 612. So what we do here, on your writing book, we are writing short notes. Take the topic as AMU, atomic mass unit. Take it as number 1. AMU, atomic mass unit. And write this down. Okay. After that, on your tube, atomic mass unit topic is there. And on that 2 lines are given. In those 2 lines, you have to write the definition. What is the definition? This definition you have to write. Okay. Then you have to write this down within the text box. You got my point? I'll repeat it. This is to be written on your writing book, and then get back to your tune, write the definition, and write this within the bracket, within the box. Right? Yeah. Capital. AMU, that is the percentage that is AMU. Mass of hydrogen one oscillations if we multiply. Yeah, multiply. That first one is mass of hydrogen one straight away they are taking because hydrogen is one. Mass of hydrogen is one, but make it fast. Right? We'll make it fast. Hurry up, hurry up. You have only one text box, right? On your tune, only one text box you got, right? Right around this one, atomic mass will be equals. Now, mass of carbon 612 isotope dividing by 12 also you can write, or you can write it as 1 over 12 into mass of carbon 612. Both same. 1 over 12 into means you are dividing by 12, right? Both same, okay? Right, it's bar. Right. Now, once again, we go to the writing book. Okay, because everything we can't be writing. Theories we are filling up in the tube. Additional things to go deep down, we are taking the writing book. Okay. Now, this part I am going to take furthermore down. That is, now we wrote atomic mass unit equals 112 the mass of carbon 612 isotope. Can you remember what is isotope? What is isotope? Okay. Element percentage. What? Having the same atomic number but different mass number. Elements with the same atomic number, different mass numbers are called isotopes. Isotopes, right? So carbon 612, 613, 614. Different mass numbers are there. We take only 612. Now, you see, I use a word like this. You take a cake. You take a cake. Now, what is the cake? Vanilla, strawberry, chocolate? That's up to you. Just a cake. Now, this cake, you're going to divide into 12 pieces. How many pieces? 12. So, If the full cake is given, what I refer to as the cake here, mass of carbon 612. This mass of carbon 612 is 1.99 into 10 to the power minus 23 grams. Can you see minus 23? So it's not so easy to always calculate. Okay, decimal numbers will be there. So this has to be taken. If the full cake is given, you have to divide by 12. You have to multiply by 1 over 12. That means you are dividing by 12. You understand? Zainab? If you are given with the full cake here, you have to divide by 12. Okay, to get the A and B. If the 1/12 fraction is given, that means after dividing that 1 over 12, 1 out of 12 pieces were given for you. Do you want to divide it again? You got my point? Full cake given, you have to divide by 12. If that 1/12 fraction, this 1/12 fraction is given, do you want to divide again by 12? No need, right? That's the idea. So, when you divide these, you get 1.67 into 10 to the power minus 24. 1.67 into 10 to the power minus 24. So, full cake means you have to divide by 12. 1/12 fraction, we don't divide again. It's already divided, but the answer. So, this is the A and U value. Some questions are there where they give the real mass of carbon, so you have to divide by 12. Some questions are there, they give the full cake, they give the real mass of carbon, then you have to divide by 12. Some questions are there, they give the 1/12 fraction of the cake. Already divided fraction is given. Do you want to divide again by 12? No need. You understand my point? Is that point clear? Fine. So shall I write this down on your writing book below this? Grams is the unit we are using here, okay? Relative to this only, others are measured. Make it fast. Uh-huh. Hurry up, please. Done. Okay, hurry up. Yeah. On the last one, when you divide, you will get the answer 0.16. Divide, you get 0.16. As scientific function, they are 1.6. So that will be 1.5. So that will be minus. So that is minus 20. Otherwise, minus 20. 0.16 is minus 20. 1.67 as scientific. That's minus 20. Yes. You are taking one, it is a principle, you are taking as 1.20. So you have to minus 20. Guys, when you divide this, actually you are getting the answer, isn't it? You get the answer 0.167. 0.167 into 10 to the power minus 23 is what you get the answer here, right? Scientific notation, when you are writing, we have to take one number front, right? You can't write 0.167, you can't write for scientific notation. So, scientific notation, you write 1.67. This is minus 23. Scientific notation, since you took one number front, you have to take it as minus 20. That is how it comes. Okay? After yesterday. After yesterday's. Then check out even before that. Fine. Look at this. Now, furthermore, we are expanding. Imagine now, look at this clearly. Look at this clearly only once. Okay? Let's take this entire piece as the real mass of carbon. Carbon 612. I'm taking this as the real mass of carbon 612. First. Right? Abdullah, okay? Real mass of carbon 612 I'm taking here. Okay? How much is it? Can you remember? 1.99 into 10 to the power minus 23. That would be given in the question. So this is a full cake. Okay. To get the AMU, how many pieces we have to divide? 12. Check if it is 12. Right? We are dividing into 12 and I'm going to take only 1 out of that. I'm going to take only 1 out of that. So 1 out of 12 I'm taking. This 1 out of 12. Out of the total mass, I'm taking 1 out of 12. This is what I term as atomic mass unit. You understand that now? This is what we term as atomic mass unit. So atomic mass unit is equal to mass of the total mass of one carbon atom. We divide by 12. We divide by 12. Is that clear now? Okay. We'll mark it down quickly. Roughly mark it down on your writing book. Okay. Roughly mark it down. Don't use now the rulers and all to nicely take all those. No, just roughly mark. But 12 pieces should be there. Okay. Take it down. Right. Okay, I hope AMU is clear. Next we go for relative atomic mass. What is this relative atomic mass? Guys, okay? I told you. Compared to this person, you are measuring the mass of others, right? You are measuring the mass of others compared to this person, okay? Now, compared to this person, when you measure the mass of others, their masses are called the relative mass. Right? Relative to this AMU, you are measuring the masses of others. So, those other people's mass, we take as a relative mass. Relative to what? Relative to AMU. You got my point? Listen. Compared to this AMU, you are measuring. Compared to AMU, you are measuring. So the length of the boat or as the width of the boat is the relative width. Relative to whom? Marker. Relative to the marker, you take the width. Relative to the marker, you take the length. You understand? So it's relative. Okay, the arm's length, it is the relative length of the arm. Relative to whom? Marker. Likewise. Relative to AMU, you measure the mass of others. So it is called relative mass. Relative. And this mass, we come to the point, atoms and molecules. If you measure the mass of an atom, if you measure the mass of an atom, any atom's mass, one atom's mass you measure relative to AMU, it is called relative atomic mass. How do you name that? Relative atomic mass. If you measure the mass of a molecule, H2O, CO2, NH3, CO, a molecule's mass you measure relative to AMU. This is called relative molecular mass. You understand? Relative molecular mass. So this is the difference between the relative atomic mass and relative molecular mass by word, but the calculation is same. Same means we find relative to one another. Relative to one another. So how do we find out the relative atomic mass? Relative atomic mass is equal to what is the real mass of the atom? We divide by AMU. The real mass of the atom we divide by AMU. AMU means 112, the mass of carbon 612 isotope. You got it? What is the real mass given? You are dividing the real mass of the atom by AMU. By AMU. So we learned earlier AMU is equal to 112 the mass of carbon 612. Okay. Then relative atomic mass, it is equal to the mass dividing by AMU. Short. What is the real mass? Dividing by AMU. AMU means 112 the mass of carbon 612. You understand? Okay. Again, how do you find the relative atomic mass? This is the atomic mass you need. This is the person. What is the real mass of this person? You divide by atomic mass. Atomic mass. Here. So if you want to take it for Rmn for a molecule, then how do you take? Same thing. Real mass of that molecule. You divide by AMU. Got it? So first three equations we learned. Okay. So accordingly, Relative atomic mass is equal to, or else we can term it as AR also. Either RA or else we take it as AR. Relative atomic mass. Relative atomic. You got the point? Shall I write this down? Go to YouTube. Go to YouTube. How many times an atom of a given element weighs as much as 1/12 the mass of carbon 612 is the relative atomic mass of that element. Oh, all the 18 exams not 80 not. You like 80 open? 29. How much? First 4 29 start. When is the session? August 5th. What about the 5 to 8, right? Because that's what I'm saying. Yeah, somewhere August 1st we want to have one exam. Right? So this month, all Sundays there will be occupied with some revision seminar. You'll get the message by tomorrow, sure. By tomorrow, the day after, you'll get all complete revising of all the chapters. Okay, taking all the question and answers. 3 Sundays you can have it. 13th, 20th, 27th. 30th, 20th, 27th, all 3 Sundays. You'll be having some sessions. Yeah, this is to be written within the text box. Text box. How long is this? Don't do too much. The piece is like right. Now you review. Okay. Not okay. Now right. We go to the calculations now. What no? Hurry up. Is it 100 of letters are there? If you close this quickly, you can finish it up. Zip it. Got it? Okay. Look at this question now. What it says? Look here. Boys. Find the relative atomic mass of oxygen. Whose mass you want to find? Oxygen. If its true mass is 2.6, take it as 2.6 because only you have 2.6. Okay. Right. How do you find out the relative atomic mass? I'll take it as relative atomic mass of O equals. How do you find? Mass of O dividing by A and B. Right? So relative atomic mass equals mass over A and B, right? Zainab, look here. Rn equals M over A and B. Okay. Relative atomic mass of oxygen is equal to mass of oxygen over A and B. Mass of oxygen over A and B. Now, what is the mass of oxygen? What is the real mass given? 2.6. I take that 6 into 10 to the power minus 23 grams. Okay. Dividing by. Can you see the true mass of carbon 612 given, right? That means the full cake is given, right? If the full cake is given, what am I supposed to do? We have to divide by 12. Correct? So, I'm writing the ANU 112 into 1.99 into 10 to the power minus 23. Got it? Got it? What we wrote now? What did you write? What is the real mass of oxygen given? 2.66 divided by atomic mass unit is straight away not given, but it is giving you the mass of carbon 61. So you have to take it as 1 over 12. Can you simplify this? Division itself is a big problem. Division and multiplication, if it comes, you are blue. Division, multiplication with fraction, decimal is there. Now totally blank. Totally blank. Right. You see, these questions are very rare. But if it comes, write the steps. Okay, write the steps. When you divide these, you get the answer somewhere 16.02 or 04. So approximately 16 grams per gram star. 16. 16. So how? Go to the next page. Second page. Can you see there's a table given? Relative atomic mass table. Relative atomic mass table. How are these? Relative atomic mass table is on. What is this? Relative atomic mass, right? How much should it be? How in that too? How in? So when you divide this, you get the answer 0.16.02 or 04. A long number it comes. No matter. Don't spend hours, minutes in finding it out. You can't do that, right? You are finding difficulty in dividing this, right? What do? Pick up the answer from the table. You write. Okay? No, you don't want to memorize. You don't want to memorize it. When you do the questions, automatically it comes to your mind. You see today, we'll be doing some questions. Automatically it comes to your mind. Oxygen is 16 will be fixed in your mind today. Not only oxygen, there are some more we'll be using. When we are doing the latter part of today's work is that. Okay? So you see, no. That's what I'm telling you. Not to memorize, yeah, but you will do. Eventually you will do that. When you practice the questions, it comes to your mind. Oxygen 16, carbon 12, it comes to your mind. Okay? It would be given in the questions as well. My point is that spending minutes, hours, half an hour you are spending just for 1 mark. Better you just write the steps you know, right? Steps you write, get the answer from. If they are not giving the mark for it, only 1 mark you are losing. That means half a mark out of 100. If you are spending hours, how many marks you are losing? A lot, right? But don't apply what I say for all the questions, okay? All the questions, if you are applying that, none of the marks you can score. These are unnecessary things, right? Unnecessary means these are very much essential, okay? Methods are what we learn here. Okay? Strictly, you know that you can't do it within time. It takes time. So, the next questions also you can see the same. Let's write this down, please. The first question. Do understand and write. Don't just copy paste. Okay? Take the mind. Mass dividing by atomic mass unit. So we write the mass first and then dividing by the atomic mass unit. Okay? Now you can try the next one. Now you can do. You don't have the tube, right? Why don't you consider only carbon and not carbon? Why do you choose carbon? No, carbon is what relatively can be taken with everyone. And also carbon is the most abundant compound. Right? And that's simple as well. But the thing is, I told you earlier we didn't use carbon, right? First we used hydrogen and then we used oxygen, so it was not working out. So carbon we took, now it is working out when? It should be relative with everyone. That's the problem. Oh. Remember, I just sent you the note.
Okay. You can do this, Ramla. I'll keep the tute at syntax. Okay. Send someone to get the tute. Telling your name, okay? I'll keep the tute here, okay? Okay, okay. Fine. Get the answer for the next one. Get the answer for the second one. What is the second one? Look here. It's about potassium. How do you write? Potassium, K, mass of potassium divided by AMV. What is the mass of potassium? 6.476 into 10 to the power minus 23 grams divided by mass of carbon 612 is equal to full K given 1.99 into 10 to the power minus 23. Are we going to divide this? No, look at the table. How much it is? 39. 39. Please write. Got the method right? 39. Very easy. That is because of you are keeping a leap between. You don't learn. That's a problem. Practicing means properly how to practice. Looking up and down. Right. Once you are done with this, go to the next one. But read the next one. Okay. Read properly the next question and write the answer. Otherwise, you have to cut it off. Right. Read it properly. Read it properly and don't just copy paste it. Okay. In the next question, is it giving you the full cake or 1/12 fraction? You have mentioned the what? Carbon's value is not given, but AMU is directly given, right? Can I say that AMU is directly given? So do we want to divide again by 1/12? Multiply by 1/12? No, right? So think about sodium, Na. What is the mass of sodium here? 3.819 into 10 to the power minus 23, right? Dividing by. So you see here, atomic mass unit straight away given. Do we want to divide again? No. Straight away, right? 1.67 into 10 to the power minus 24. Got it? You will get the answer 2.28 into 10 to the power 1. 22.8, which is equal to 23. 23. So you see, in all these relative masses, we don't have a final unit. Why gram to gram per and more? Furthermore, anything relative to one another means we don't have a unit. We don't have a final unit. Okay. Right. Try the next one. Try the next one. Read it properly. Okay. The mass of the element is directly not given. It is given as an equation or as a substitution. It is given actually. Compared to carbon, it is given. What does it say? Mass of an atom of element A. We don't know who is A. E is 8 times the mass of carbon 612. Does it give you a value? Does it give you a value? No. But it says mass of A is equal to 8 times the mass of carbon. Mass of carbon. Okay. So, if you want to find out the relative atomic mass of A, you have to take mass of A divided by AMU. Correct? Correct? Right. Now, hit else. Mass of A is given? No. But it says it is equal to 8 into mass of carbon, right? So, I'm writing 8 times mass of carbon 612. Right? Dividing by, what is AMU? 1/12 into mass of 612, isn't it? 1 over 12 into mass of carbon 612, right? Correct? Correct? So, what I can do now? I can. Correct? Correct? Now, 8 over 1 over 12. Again, you are strong. 8 over means division 1 over 12. Okay? Multiplication. So, what happens? Correct? Correct? So, 8 into 12. It is 96. You understand? Is that clear? So, why you mistake in physics? Because of maths. As usual. As usual, this is the problem. Correct? Fine. Done, right? Done. Okay? Hurry up, hurry up. Okay. So this is the table given. You don't want to memorize it, but eventually I told you some of the points you will get to know. And anyhow, it would be given in the questions, right? Next, relative molecular mass. Relative molecular mass. I have already explained you. Let's write that down. So the equation, what is the mass of the molecule of an element or compound divided by A, correct? Relative molecular mass. This is what the total idea. In short and sweet, you can remember this. Mass divided by A. It is not must have been right completely, okay? Theories, book should be completed. The theory should be completed. So we are writing this. Short code, RMF equals to mass divided by A. That's all, right? Do it. And then you can try the question there. Hurry up, please. Right. Writing. Now, if you are speaking, I have to take it as you are done. Huh? What are you doing now? You're speaking. You're speaking. Fine. Look at this question. How about this? Relative molecular mass of carbon dioxide. So, mass of carbon dioxide divided by atomic mass unit. Okay. What is the mass of carbon dioxide given? 7.31 into 10 to the power minus 22. What is AMU? Real mass is given. Real mass means 112 into mass of carbon 612. It is 1.99 into 10 to the power minus 23. Now, we don't want to divide it. We have to get the answer. But the thing is, it is not an atom. Earlier atom, we got it from the table. Now what do you do? What I will do? I have a set of markers. If you want to find out the total, what are you supposed to do? Each of them you have to take and add them, right? Correct? So you'll get the total, right? Correct? So, carbon. Yes? How much is carbon? Look at the table. How much is carbon? 12. How many carbon are there? Only one carbon. CO2. We don't say C2O2, right? CO2. C1O2, right? C what? 12. Okay, 1, 12. Plus 16. Okay. 2 into 16. So how much is carbon? How much is oxygen? I told you, right? Eventually you will get to know. You don't want to memorize. What is the total? 45. So, 40. Yes. Yeah. What is this? Yes. Total atomic mass, right? Total atomic mass is what? Equal to molecular mass. Okay. Short methods. Right? Short methods I am giving you to learn easy. Okay. Total atomic mass is what equal to molecular mass. Right? One atom, two atoms, three atoms. Collectively, total number of atoms. Total is equal to, as a molecule, molecular mass. Right? 41. Is it hard? Fine. So 3 equations we have done. We have one more for today. We have one more for today. Already we learned. What is that? Already we learned that. We are going to calculate now actually. What we learned now? Total. So, I'll write here. RFM. RM, relative atomic mass. RMM, relative molecular mass. RFM, relative formula mass. Relative formula mass, price formula mass. Relative formula mass is taken for ionic compounds. What compounds are they? Ionic compounds. But when we are calculating, commonly everything I have given for you to get it, okay? Just to practice. So, relative formula mass is taken for ionic compounds because ionic compounds chemical formula are taken not as a whole, but the simplest form is what taken. Simplest form is what taken for ionic compounds. So we have to find out relative formula mass. How do we take? As I told you now, sum total of relative atomic mass. Sum of the relative atomic mass. What is the total of relative atomic mass? Is equal to RFM. Is equal to what to memorize? You don't want to memorize. Did you memorize that carbon 12 and 16? No, right? We just told, right? Because you saw that 1-2 times. Automatically goes to your mind. You check it out with the next questions. Okay. So you see, relative formula mass, let's write there. Relative formula mass. In ionic compounds, what is calculated as the relative molecular mass is the mass relevant to their empirical formula. That is simplest formula. Empirical formula means simplest formula. Simplest formula. It is known as the relative formula mass. It is known as the relative formula mass. Right? Example. Sodium chloride. Sodium chloride is NaCl. How much is sodium? Only one sodium is there. 23. Plus only one chlorine is there. Check how much is chlorine. 35.5. Correct? How much is chlorine? 35.5. Now itself send it to your mind. 35.5 is chlorine. And then 58.5. So that 58.5 is the relative formula mass of sodium chloride. Sodium chloride is an ionic compound, so we get the relative formula mass. Same way you can find out the relative molecular mass also. Relative molecular mass also you can find. And as a mixture of all the compounds are what I have given you in the next page. 1 or 2 examples I will do and I'll give you a break. After that, you can continue. Okay? What is it? Yeah. Yes. Okay. But just let me know what are they. What is the first one? Nitrogen, right? First one is nitrogen. Okay. Look at this. How do we do? It's very easy and pretty interesting. You see there? What is it? 2 nitrogen. Okay. Then first write the number. First write the number. 2 into how much is nitrogen? Check out the label. 14. Nitrogen is 14. 2 into 14 how much? 20. That's all. No unit. No unit. With the next one? Oxygen. 2 into how much is oxygen? 16. Now remember, right? Oxygen is 16. 2 into 16? 32. Who is next? Carbon dioxide. 1 carbon. Carbon is 12. 2 oxygen. You see CO2. Carbon 1, O2. 2 into how much is oxygen? 16. 12 plus 32. 40. 44. Okay. Who is next? H2O. 2 hydrogen. How much is hydrogen? How much is hydrogen? 1. Send it to your mind. Hydrogen is 1. 2 into 1 plus oxygen. Now you know oxygen 16. How much is the total? 18. Correct? Is it hard? Only thing you have to take the number of atoms needed. Number of atoms needed and get me the answer accordingly until you can go up to almost 21. The first 21 you can write. The first 21 you can write. 22nd one onwards I have to explain again. That is a different story. When you are counting on, when you do it, you can see one somewhere you struck. Somewhere means bracket questions are there. They will struck. I'll explain that. Okay? Or else take that film. Take with this person. Can you see this person? CaOH twice. Take that CaOH twice. How do you do that? How do you do? Then you can completely do. Okay? Second part also I'll explain. No, check. Calcium. How much is calcium? Check out the table. Calcium 40. Look at this. Look at this everyone. Now plus. Okay? It is a bracket, right? Start the bracket. Open the bracket. Oxygen how much? 16. Now you know. How much hydrogen? 1. Good. Close the bracket. Number 2 is there, right? Multiplied 2. Okay? 40 plus 16 plus 1 into 2 34. Sorry. That's it. Okay, that's all. So all of them are within the first 20 elements except 3 of them. What are they? Copper, there is a point. Take copper as 63.5. Ferrous, Fe. Take it as 56. There is another point given. KMnO4. It has to be K, capital M, simple N, O4. Change it. Okay? KMnO4 given. N is given as capital. That is not capital today. Change it, simple N. Okay? And that is actually manganese, Mn. Take Mn as 54.9. These are the only three which is not there within the first 20 elements. All others are within first 20s. You got my point? These three are given. Others that is already there within that periodic that the table. Do complete it quickly. You can take a small break now. Okay. For 5 minutes and then you can continue. Yeah. Go ahead, please. I gave you this. Why did I give you? To continue. This is 22nd one, right? Fine, man. Give me the answers. Who is the next one here? This give my kids. Okay, tell me. You just go ahead. Can you tell me the next one? Who is the next one after H2? Chlorine. Cl2. So 2 into 35.5. 71, right? After that. NH3, ammonia. 14 plus 3 into 1. 17, correct? Yes. Correct? Yeah. What's next? HCl. 1 plus? CL. 35.5. 36.5. What's next? CH4. 12 plus 4 into 1. 16. Next? NaCl. 23 plus 35.5. 58.5. What's next? KOH. 39. Potassium 39 plus 16 plus 1. 56. 40, 56. Okay, who's next? Sodium hydroxide. NaOH means sodium hydroxide. Sodium 23 plus, oxygen 16 plus, hydrogen 1. Total 40. Next. MgO, magnesium oxide. Magnesium 24 plus, oxygen 16, 40. Right? Next. Who's next? H2S. H2S. 2 into 1 plus 32. It is not silicon, sulfur. Okay. 34. Next. K2. O. 2 into 39 plus 16. How much? 94. 78, 88, 90, 94. Yes, 94. Next. Silicon dioxide. It is not sulfur. Don't confuse with these two. Okay. Si means silicon. 28 plus 2 into 16. How much is it? 60, right? What's next? H2SO4. 2 into 1. Sulfur 32. Oxygen 4 into 16. What is the total? 98, right? Next. 68. CaCO3, right? Carbon, calcium 40. Carbon how much? Carbon 12. Oxygen 16, right? 3 into 16. Carbon 12. Oxygen 3 into 16, right? What's the total? 100, right? Next. L NO3. Is that so? What's the next one? Al2O3, right? Al2O3. 2 aluminium. How much is aluminium? 27. 27 plus how much is oxygen? 16. 54 plus 48. How much is it? 102. Right? 102. HNO3. Hydrogen 1. Nitrogen 14. 3 into 16 oxygen. How much? 48, 58, 50, 62, 63, right? 63.
CuSO4, copper sulfate. CuSO4. How much is Cu? 63.5. Sulfur 32. Oxygen 4 into 16. 32, 64, 64, 94, 96, 96. 159.5. 159.5. KNO3. Potassium 39, nitrogen 14, oxygen 3 into 16. How much? 3 into 16, 48, 58, 62, 92, 10. Yes, 10. Calcium hydroxide I did. Okay. Have you all done with the electrons? Fine. Do it at home. Do complete it. Okay. So practice all four equations we are now. That's we live in the homework is there in yeah, one guy. You complete it. Okay. Complete the entire part. So what did we learn today? We learned about AMU, atomic mass unit. RAM, relative atomic mass equal mass. So what is AMU? 1/12 the mass of carbon 612. Relative atomic mass is equal to real mass divided by atomic mass unit. RMM, relative molecular mass, is equal to real mass of a molecule divided by atomic mass unit. RFM is equal to sum of the RAMs. These are the four. Four more remaining to the next class. Okay, that is one lesson. Okay, I'm giving you in an organized way to make it easy accessible. But if you forget all these things and come as a new, totally blank, you won't understand the rest of the part. So please refer all what you have learned. Do practice those questions. Okay, clear the points, right? Fine. We are ending up with that. Regarding the e-test, we will be we are holding up for some time. That's because I told you the guys are not ready to do it. I can't do. Okay, not everyone joining. Not everyone joining still. So I'm holding it up for a while. And then please be updated with your WhatsApp groups, the class groups, regarding the upcoming week's seminar series. Okay. We're gonna have some seminar series as to revise before the second term, inshallah. So probably the August first week we are having it. So like a series of session on Sundays, we are going to make it on. You will get the updates as soon as possible. Okay. That's all. Please update you and it's gonna be an open session for all. Okay. See you there. No. Okay, salam. See you then. Salam. Salam. Yeah, RFM is equal to sum of RAMs. Okay.